Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So this will be the last topic for this chapter. We will cover on the type 2 of improper integral, which is infinite discontinuity. So these are the example of the infinite discontinuity. As you can see, at x equals to 2, the function is not continuous. Okay, same goes with this one and also this graph. Alright, what you learned yesterday is the type 1 of improper integrals that concern the area of region that extends infinitely on the horizontal direction. So which means that the interval starts from a number up until infinity, or it can be from negative infinity to the infinity, or from negative infinity to a certain number. So that is type 1 improper integral. So our main focus today is the type 2, where type 2 involve the function that have vertical asymptote, where the integrand has infinite discontinuity at specific points. For example, here is x equals to 2, or points in the interval or at the endpoints of the limits of integration. So which means that let's say you have to find the integral between 1 up to 4. So you can see that between 1 and 4, there is a vertical asymptote where x equals to 2, where at this x equals to 2, the function is discontinuous. Okay, let's say we have an unbounded region, okay, under the graph of y equals to f of x, okay, and above the x-axis between interval a and b. So here, the region is infinite in a vertical direction at x equals to b. Okay, now let us assume there is an interval t here where t is very close to b. Okay, since at x equals to b, it has infinite discontinuity here. So, to find the area of the part of S between a and t will be a of t equals to the integration of fx dx from a to t. Okay, so let's say we have the area of t where we define it as the integration of fx dx from a to t. So as t here is approaching b to the left, from the left, okay, not to the left, from the left, it is approaches a definite number. So the area here approach a definite number where we denote it as c. So we can say here, okay, I just repeat again, the area of the curve of the region of AT from interval a to t, let's say it approach a definite number which is c. Then we can also say that the area of the region of S, where S is denote the region between A and B, is also equals to C. Okay, here we can write it as the limit or the integration of fx dx from A to B is equals to the limit of the integration of fx dx. Okay, so the interval would be from A up to t, where t is approaching B from the left. So here you can see there is a sign minus here. So what does it mean? So the sign shows the direction from which you approach x naught. Okay, for the previous example is x equals to b. So which direction from which we approach x equals to b? So our t is on the left of b. So which means that we approach t approach b from the left side. So from the left side, it will be minus sign. Okay, and then if our x naught here and t is on the right side, so which means that the limit as t approaches x naught will be from the right side, so it will be positive sign. Okay, now let's go through the differences in the type 2 of improper integrals. Okay, the first one is, let's say we have a function of fx that is continuous in the interval a to b, and it has infinite discontinuity at x equals to b. So for this, we can write it as from a to b, okay, to find the area of fx dx. So we have to find the integration. So we can define this as the limit of a to b, since our t will be on the left side of b, so our t will approach b from the left. T is approaching b from the left of fx dx. So here you could see the interval is from a up to t, where t is approaching b from the left. Okay, the second definition of type 2 will be this one. So if f of x is continuous in the interval a and b, but now it has infinite discontinuity at x equals to a. Okay, so it has infinite continuity. So we can write our integration, where this would be the integration of fx dx from a to b, where this will be defined as the limit. Okay, here we have our t is on the right side. Okay, so as t approaching to a from the right, so this would be defined as t to b, as t approaching a from the right. So it will be positive sign fx dx. Okay, so for both cases, okay, for this case and the previous case, the improper integral is convergent if the limit exists, which means that it has a finite number. And the integral will be diverged if the limit does not exist. So this is the last definition for type 2 improper integral. Okay, let's say we have our function is continuous in the interval a and b. However, in the middle, okay, somewhere in the middle between a and b, there is a discontinuity, infinite discontinuity at x equals to c. So to find the area, okay, the integration of fx dx from a to b, so we have to find this separately. For the first one, okay, the first part would be from a to c of fx dx, plus with the second part would be from c to b. So for this case, the integral would be converged if only both improper integrals, okay, meaning that the first one and the second one is converged. Okay, if both of these converge, then you can say that the integral of this is converged. Otherwise, if either one or both of the improper integral here is diverged, okay, meaning that this one is diverged and this is not, this integral would be diverged. Okay, let's say if the first part is converged, but the second part is diverged, still it is diverged. The integral is diverged. And if both of these integral is diverged, then surely the integral of f of x dx from a to b would be diverged. So you have to check both of these integral to see the divergent or convergent. Now let us try this example. Okay, you can see here the interval is just like a definite integral where it starts from 0 up to 3. So please beware. Okay, what you have to do is you have to find your denominator. Is it between this interval or this interval that makes the denominator equals to 0? So how to find how to find the value of x that makes the denominator equals to 0? It's just that make the denominator here 3 minus x as equals to 0. So you can find here x equals to 3. So which means that at x equals to 3, the denominator will be equals to 0. So which means that here we can define this integration as the limit from 0 up to t. Okay, so here we have our interval between 0 and 3. So the t would be on the left of 3. So t would be approaching to 3 from the left. So since it is from the left, the sign would be minus. So now we can solve the integration 1 over 3 minus x dx. Okay, so you can straight away solve this. Okay, but make sure that you have to write the limit. Okay, so now we can solve this integration. It's either you solve this straight away or you can solve this separately. So which means that if we have to solve this 3 minus x dx, so I just bring this to the numerator. So it would be equals to 3 minus x to negative 1. So this would be the answer. So the limit of this is negative 2, 3 minus x to the power of half. So the limit is from 0 up to t. The interval is from 0 up to t. So now we can substitute this. Negative 2, 3 minus t minus with negative will be plus 2, 3 minus 0. So now it would be 3 minus 3, negative 2, as t approaching 3, so 3 minus 3, half plus with 2, 3 to the power of half. So this one will be 0 and this one will be equals to 2 sec 3. So since we have the value of finite number, which means that the integral converge. Pause this video and try this example 5. To determine if this integral converge or diverge. So now what we need to do is we have to determine the discontinuity at which interval. So you can see here when x equals to 0, So the denominator would be equals to 0. So which means that, okay, the discontinuity is here from 0 up to 1. So your t will be on this right of 0. So the limit will be t up to 1, where when t is approaching 0 from the right, which means that the symbol or the sign will be plus dx over square root of x. So you can solve this separately. So 1 over square root of x dx will be equals to x half 2x squared to square root of x. So this would be the answer for the integration of 1 over square root of x. So we can just substitute into this, where it will be 2x to the power of half from 1 to t. So here we have this 2 times with 1 minus with 2 times with t to the power of half. So here we have 2 minus with t is approaching 0 would be 0. This part would be 0. So 2 minus 0 would be 2. So here we have the integration of dx over square root of x. Okay, as interval from 0 up to 1 would be equals to 2, which means that the integral converge. Okay, now let's try the last one. Here you can see the function here. We have 1 over x to the power of 2 over 3. Okay, then determine if the integral converge or diverge. So first of all, what you need to do is you have to define where the infinite discontinuity happen. So here we know that when x equals to 0, it means that the function has infinite discontinuity. So you can see the interval start from -1 up to 1. Cool. Which means that at x equals to 0 here will be our C lah. Okay, so here we have to separate this. Okay, we have to separate this integral from -1 to 0 dx over x to the power of 2/3 plus with from 0 up to 1. Okay, now we have to solve this part by part. So first we solve this part, and the second one we solve this part. Okay, let's say if the question here -1 up to 3, okay, dx over x minus 1 to the power of 2/3. So now you can see if x equals to 1, okay, which means that the denominator would be equals to 0. So you can see the interval from -1 up to 3, and when x equals to 1, there is a infinite discontinuity happen here. So for this case, your interval would be from -1 to 1, right? Dx over x minus 1 to 3 plus with from 1 up to 3. X minus 1 to 3. Okay, so this it depends on where the infinite discontinuity happens. Okay, you cannot just assume it as in the middle of the interval. Okay, so just go back to the questions where we have to solve the first part and the second part to determine whether the integral converge or not. Okay, so first of all, let me just solve x to the power of 2/3. So this would be negative 2/3 dx, where this one would be x to the power of 1/3. So this would be the answer for our integration. So now let's solve the first part. The first part, from negative 1 to 0. So we know that the interval happened between negative 1 to 1, where the infinite discontinuity happened at 0. So our t, so for part 1, our t would be on the left of 0. So we will write it as limit of from negative 1 up to t, where t is approaching 0 from the left, so it will be negative sign of dx over x to the power of 2/3. So we have solved this, where the answer of the integration is 3x to the power of 1/3 from negative 1 to t. So substituting this, you will get 3t to the power of 1/3 minus with 3 negative 1 to the power of 1/3. So for this one would be 3 times with 0 to the power of 1/3, which is 0, and this one would be minus 3 times with negative 1, which is equals to 3. So now we have solved the first part. Okay, so since it is converged, now we try to solve the second part. For the second part, it would be from 0 up to 1. So here your limit, okay, will start from here to here, where your t would now be on the right side of 0. So your t will approach to 0 from the right. So your limit would be from t to 1, as t approaching 0 from the right would be positive sign, dx over x to the power of 2/3. So limit of this would be 3x to the power of 1/3 as t approaching 0 from the right. Three times with 1 to the power of 1/3 minus with 3t to the power of 1/3. So for this one would be 0, and this one would be equals to 3. So now we have solved the first part and the second part. So we just combine this, where the first part would be equals to 3 plus with 3, which is equals to 6. So which means that since we have a definite number, the integral converge to 6. Okay, so that will be the end of the chapter 2, improper integral. So from now on, whenever you meet the integration of fx dx from a to b, you have to decide by looking at the function f on interval a to b whether it is either an ordinary definite integral or an improper integral. So by now I think you already know the difference between these two integration. Okay, that's all for today. Thank you everyone.